Hello and welcome to the second video entitled Mathematics and Mysticism, and I have a treat for you with this video. This is actually a talk I had given, and so that means this is all official. I've got a PowerPoint slide and pictures and all these sorts of things, and as long as I've done a better job on presenting this already in a more thorough way than I am taking on these slides, which I'm just sort of doing as a recreational project, I thought might as well just make use of that, and we'll go through that PowerPoint presentation I have. I'll talk you through it and we'll take a look what's going on there. So just real quick, what did we set up? Well, we had left off at the end of the Dark Age following the 1200 BC collapse in Greece. Greece was just getting its feet under it again. The two big civilizations were still Egypt and Babylon. They did have a lot of math and stuff like that going on there, but there was something different about the Greek math and philosophy that was coming up that would set it apart. And it's that difference which I'm sort of identifying as what I'm calling real mathematics and what is the subject matter of this series of videos. So let's take a look here at my presentation, and here we go, Mathematics and Mysticism. So let's take a look at what we have going on here. So first of all, why am I interested in combining religion and mysticism in a talk on mathematics and the history of mathematics? Well, to answer that, let me start with an analogy I heard in a lecture I listened to once. It goes like this. So imagine you really enjoy eating, you really enjoy food, and you're looking for a good vacation idea, and your friends suggest to you that you go to Paris because it's got great food. So you travel to Paris to see what kind of food they have there. Now, being an American, of course, you know that the height of cuisine would be McDonald's, right? And you go there looking for McDonald's, and yeah, you find a couple there, but first of all, not as many as there are in America, and secondly, it's not really, you think, as good as American McDonald's is. So you end up coming home quite disappointed. Now, we might say, imagine if that American traveling in Paris had expanded their mind a little bit. Instead of taking what they thought of as cuisine into the area and looking for that, if they saw what the natives there decided was cuisine and sort of expanded their horizons and scope. Now, I'm not saying that they guarantee like everything. I mean, you know, eating snails might not be your thing, but I'm sure that you would have found a lot of stuff you liked, and it would have broadened your perceptions of food beyond just McDonald's. So here's the thing. In history of mathematics, you have a lot of people interested in mathematics going in there. So when they go back and look at the origins of these things, they're focusing in on what they think of as mathematics. So going back in there, trying to extract the mathematics from what was going on, it's kind of like the American going to Paris just looking for McDonald's. What if instead we got there and we said, well, what do the people there think about what they're doing? You know, what is their perspective on things? And we should try to broaden our mind in that way. Now, again, we might not like everything we see, might not be our cup of tea, but it'll definitely broaden our horizons. And so at the time, at the time, mathematics started in sort of the mystical religious bent, and you'll see this if you go back and look at writings in the history of math on the Pythagoreans. They'll always say, oh, these guys were mystics, and do a few offhand comments on how they wouldn't eat beans or believed in reincarnation or all that stuff, just almost as sidebars to make them seem more interesting, but never really get into it seriously or actually try to understand, you know, what those people thought about what they were doing. So I am a big listener of the Audible Great Lectures series, and one I listen to is called The Religion of the Axial Age by Mark Moisey. Great courses in Audible, and that really struck me and connected with all of the stuff I am personally interested in the history of mathematics and in philosophy. So I connected those things together in this presentation to try to give you a presentation of what the Greeks thought about what they were doing, instead of necessarily what modern day historians with their own sensibilities and their own sets of interests would try to surgically extract out of what the Greeks were doing. Okay, so what is the Axial Age? The Axial Age is a period of time from 800 to 300 BC in which there were big innovations in thought throughout religion. I will use Greek religion as a canonical example of a pre-Axial Age religion in illustrating. So what were some of the points and innovations of the Axial Age? I'm not going to talk about all of them. I'm only going to talk about the ones that are relevant to the mathematical issues we're discussing in this talk here. So first of all, a characteristic, a new idea of the Axial Age was a sort of otherworldliness of religion. Let's take a look at the Greeks. The Greeks had gods, but those gods, they actually lived on Earth. They were up in Mount Olympus, which was an actual place on Earth. At any given time, Zeus was somewhere, possibly missing something going on somewhere else. There was a hell, but you could get there through a cave on the coast of the Mediterranean, and it was just underground. The idea of like there being another world was something that didn't occur to people until the Axial Age. Another characteristic is that there's an afterlife and the persistence of the individual as a supernatural soul. Now, the Greeks believed that when you died, this sort of weak shade of you went down into this afterlife underground. But it really wasn't the notion of you persisting. It was just a shade, an echo of who you were. It was during the Axial Age which the notion of you actually persisting in your fullness or even more than you were in life came about, and that there was some otherworldly place where you as a person persisted in fullness. This was a new innovation of that time. Also, the idea that religion was universal instead of just tribal. The Greeks believed in Greek gods, and if they went down in Egypt, the Egyptians believed in Egyptian gods, and the Jews believed in Jewish gods, and so on and so forth. And everybody didn't have a problem with that. Gods were tribal. But a new notion of the Axial Age was that religion may be universal, that it might talk about a reality that transcends tribalness. And so these are all going to be important points in developing of what I'm calling real mathematics. All right, so first, let's take a look at an example of a post-axiomatic or Axial Age religion. Iranian Vedic axial. So there was this one group of people that split. Some of them went to Iran, some of them went to India, which is the Vedic. And we're going to take these, I just talked about the Greeks as being pre-Axial Age. We're going to take these as examples of Axial Age religions. So in Iran, there was a prophet by the name of Zarathustra who came around and spread a religion which is one of the earliest Axial Age religions. And in this religion, they worshipped Ahura Mazda, which was really the supreme of the god, and which he taught was really the ruling god everywhere of everyone, doesn't matter what tribe you're part of or anything like that. Secondly, that the whole religion rotated around an axis of truth, that to be good is to tell the truth and to be evil is to tell a lie. Their whole morality system was about truths and lies, and that this was a universal religious moral system, not just for the Iranians or the Zoroastrianisms that believed in this. Also, they believed that your soul was judged in the afterlife, that you had a soul, it persisted after you were dead, and there was an afterlife, and that ultimately you are judged on your adherence to the ethical principles around which the religion was oriented, judged by Ahura Mazda. So these are some real characteristics of Axial Age religions, and taking a look at Iranian, so this is Vedic Hinduism, a bit earlier than the classical Hinduism I talked about before. And the one thing I'm going to bring up from Vedic Hinduism is that's where the earliest notions of reincarnation came from. So again, we have a persistence of the soul and an afterlife. You at least spend a brief amount of time in between lives here. So those are some characteristics of Axial Age religions. All right. Now, the real question, what am I calling real mathematics and why am I calling it real mathematics? So we're going to the Greeks. And this is the sort of birth of Greek philosophy. What about Egyptian or Babylonian? Well, Egyptian and Babylonian religions were sort of this pre-axial mindset. They had tribal gods. It was all worldly. It was about being on this earth. It wasn't otherworldly, and it wasn't universal. And also, backing up a minute, if you want to take a look at their mathematics and their sciences that they did, I did say that they were doing a lot of that, but it was always very concrete, very much to get things done. We're going to see that the Greek mathematics was a lot more, what's the word I'm looking for? Esoteric, maybe? Knowledge, learning things sort of almost in a more spiritual level than in order to get things done. So let's take a look here. So the first recognized philosopher, Greek philosopher, was a guy by the name of Thales in about 650 BC. And he was also credited with giving the first proof that if you take a semicircle, so half a circle, and you inscribe a triangle in it, so one side of the triangle lays on the diameter of the semicircle, and the corner opposite lays on the edge of the semicircle, that corner opposite is going to make a right angle. Might not seem obvious, but you can actually sit down and prove it. And so this was the first sort of instance of rigorous mathematical reasoning in Greek history. Also, we introduced rigorous definitions of things. So instead of just getting by, if it works, good enough is good enough, really trying to be rigorous and getting precise. One of the themes I said about this series is we're oscillating between if it works, and really trying to be rigorous. Egyptian Babylonians were if it works, and the Greeks are really trying to be rigorous and careful about all of these things. So for example, they will define what a point is. A point is that which has no part. They will define what a line is. A line is breadthless length. Okay, so this might not really seem very religious to you yet. It might not seem like it fits into this post-axial age religion schema I'm laying out. But let's take a look at this a little bit further. Let's take a look at this a little more deeply. Now we're going to jump way ahead to an artist by the name of Rene Magritte. And he did a series of artwork called The Treachery of Images. And so this is a picture of one of his works. Underneath in French it says, "This is not a pipe." So you might look at that and say, but it is a pipe, right? Well, no, the point he's trying to make is that this is not a pipe. This is just a picture of a pipe. It is an image of a pipe. He wants you to look at this and not reflect on the pipe it should be representing, but how it behaves as an image. You are supposed to look at this as an image, and that little "this is not a pipe" underneath it is supposed to bring that point to, and you're supposed to think about it. We can recognize this as a pipe because we maybe have familiarity with things like this. When we look at this, we might be able to imagine how this feels, how heavy it might be, how it might smell, how it might balance in your hand. And that's because we've had experience with things like this. So what we're looking here is an image. This is not a pipe. This is an image of a pipe, but it calls up in us images and of experiences we've had, with which we can see this and recognize this image as being the image of a pipe. Okay, now let's go back to these definitions. A point is that which has no part. A line is breadthless length. And here's some wonderful pictures of points and lines I did myself. Yes, very much. And let me ask you this. Is this a point? Is this a line? And because I just set this all up with the whole treachery of images, Rene Magritte thing, you can see what I'm trying to get at is, no, this isn't really a point. This is the image of a point. A point is that which has no part. And this little squiggly thing I drew here has got lots of parts to it. You can see all the loops and whirls I make. And this line is breadthless length. Well, it is pretty thin, but it's not entirely breadthless. It has very thin breadth to it. So these are not actually a point and a line. Just like in the Magritte picture, this is an picture, an image of a point or a line. But here's the problem. We recognize the picture of a pipe as being a picture of a pipe because we've had experiences of things that look like it. We've had experiences with pipes. We've had experiences with things shaped like that, and so on and so forth. How do we recognize these things as a point and line? What in our life makes us look at these and say, oh yes, I recognize that. That's the image of a point. Oh yes, I recognize this. That's the image of a line. What actually is a point? What actually is a line? How do we have experiences of them so that we can recognize these crude images of them? They are what we might refer to as abstract objects. Abstract meaning we haven't really encountered them in real life, but we seem to be able to recognize them when we see them and reason about them. So let me take a moment here to pause and try to set up the whole argument reasoning of this talk. First of all, when I say real mathematics, I mean rigorous mathematics. That means that's stuff that you really prove. That's why I rule out 2 + 2 is 4, or college or a high school algebra, or the class that's called college algebra, or things like that. And I would say that the first real mathematics class students take is whatever one they start having to do actual rigorous mathematical proofing. Proof requires rigorous definition. In order to be able to reason exactly about things, you need to spell out exactly what those things are. Now, here's the problem. real world objects are messy. We can't come up with rigorous definitions of real world objects like a lamp or a chair. The objects of real mathematics, then, must be something other than normal real-world objects. We call those abstract objects. Lines, points, triangles, whatever, are abstract. We never really come across them. We just somehow are able to miraculously recognize images of them. The Axial Age innovation of the notions of otherworldliness opened the gate to abstract objects, otherworldly mystical objects. So let me say this. So this is how the Pythagoreans, the first mathematicians, really understood these things. A point and a line are otherworldly, mystical, abstract objects. So Plato. Now let's move ahead to Plato. It is said that he had over his arch, over his door, let no one ignorant of geometry enter through this door. So why did he have such a high regard for geometry, and what role did it play in his philosophy? Well, first of all, let me spell out here. Plato was a Pythagorean after leaving Athens, and I'll talk about this more in the future. But after he left Athens, he was taken in as a slave to a tyrant, Archytas of Tarentum, who was in southern Italy. And Archytas was a Pythagorean, and through this experience, Plato was exposed to a lot of the Pythagorean ideas that we've been talking about so far. Plato's theory of the real. So what Plato said was this, is that the longer and more persistent a thing exists, the more real it is. So for example, a rock would be more real than a whiff of smoke, and a house would be more real than just a little rock, and a mountain would probably be more real than a house. So then the question is, what sorts of things are the most real? 2 + 2 = 4 will always be true. And so these abstract objects, the number 2, would fall into the actual most real things, because it is the most eternal, most persistent things in the world. And then he threw into this, he added in from the Pythagorean notion of numbers and abstract objects, he also added in things like the concept of truth and beauty and stuff like that into the most real stuff. But that started with mathematics. And so how do we know about abstract objects? Where does our knowledge of them come from? Well, let's take a look back to math. How do we know about mathematical objects? So the method of mathematics can illustrate how we know abstract objects, which are the most real things, and then we can adapt that method of mathematics to philosophy. That's why let no one ignorant of geometry enter in through this door, because knowing geometry means you know the method of mathematics, and that's a prerequisite for doing Plato's philosophy. We know things, and what is that method? It's by proof. We prove things. All right. Now there's a problem here, and what's the status of definition and axioms? We don't prove definitions, we just give them. We don't prove axioms, we just say they're true. Axioms are where we start our reasoning process. We always have to start from somewhere. And how do we know those are true? We can't prove everything. All right, well, let's take a look at Euclid's axioms and see what they say. And this is my own wording of them. Very intuitive, not rigorous at all. Not like what you would find in Euclid's books. So first, given any 2 points, we can connect them with a line. In Plato, by line meant line segment. So given a line, we can extend it further. All right. Given 2 points O and A, we can trace out a circle with a center at O and radius OA, like that. Any 2 right angles are congruent. So given any 2 right angles, we can slide them around and match them up on top of each other so that they're equal. And given a line and a point not a line, there's exactly 1 line through that point that's parallel to the given line. That's not actually how Euclid articulated this. This is something that came later called Playfair's postulate, but this is Euclid's 5th axiom, or Euclid's parallel postulate. All right, now the question is, how do we know those things are true? How do we know that the definitions of point and line really are correct and refer to points and lines if we've never seen actual points and lines? How do we know those axioms of mathematics are true if we don't prove them? We start there, we assume them, and they're about these abstract objects. So let's see, how do we know the axioms are true? Plato's answer? Reincarnation. There you go. That as we die, our soul takes a little trip through something that later philosophers have called Platonic heaven, and then when it's time, they're reborn again in their new life. While you're in Platonic heaven, you actually see lines and points and triangles, abstract objects, experience them directly. You forget about them when you're born, but through your life, when you see them again, you recognize them. Oh yes, that's a point. Oh yes, that's a line, because I experienced them when I was in between lives. All right, so he got the idea of reincarnation from the Pythagoreans, but where did they get it from? This is actually the first, with the Pythagoreans, was the first instance of reincarnation known in Western philosophy in that region. And so some people have speculated that Pythagoras got it from possibly the East, possibly India. He's been said to travel around a lot to Mesopotamia and Egypt, and possibly he ran into merchants or travelers from India in those places and learned about it there. We don't have any evidence of this, but given that the idea of reincarnation had come up in Hinduism much earlier, and that places, big cities in Samaria and Egypt have a lot of travelers through them and stuff, and Pythagoras went through there, possibly he met some people from India there, picked it up from there. So this could be how these axial age innovations and ideas came from east to west to Pythagoreanism, and then through Plato became the foundation of Greek philosophy and rigorous, what I'm calling real mathematics, which means the study of abstract objects, not just doing calculations for building stuff. All right, and this is also the first appearance of the notion of a soul in Greek thought. Like I said earlier, in Homer's, was it the Odyssey, you do run into people after they're dead, but it's not quite a soul as much as it is just a shade, an echo of the person, hardly even mentally there anymore. This idea that your soul will then persist in an afterlife and come back again, and then can remember things that it experienced in that afterlife. That's how you recognize numbers and geometric objects and stuff. It's the first appearance of that idea in Greek thought as well. All right, so what's the story so far that I've told? So first, this is how Plato says, the more unchanging a thing is, the more real it is. The most real thing of all would be mathematics, what I'm calling abstract objects, and abstract concepts like truth, justice. This is sort of what Plato brought to the party. Math provides the methodology for knowing things about these. Mathematical proof, that's how you know about abstract objects, except it doesn't quite explain how we recognize the accuracy of definitions or the truth of the axioms. So, reincarnation, trip through the Platonic heaven, is where we actually have experienced these things in the past, where we've recognized them from when we come into the real world. And we recognize the definitions are talking about by recalling these between life experiences. We recognize the truth of the axioms by recalling our between life experiences. Now, what's this? I'm not saying that as a mathematician, you are dogmatically obliged to believe in reincarnation. The very next big known mathematician, Plato's student, Aristotle, rejected this. He thought this was sort of ridiculous and crazy. And I'm going to give you an example of some other arguments people have made, some other explanations people have given on this since then. So, for example, maybe you don't buy the mysticism, but how would you answer the following questions? What is a line, really? How do we know about lines? What are our core experiences of lines? How do we know the axioms of Euclidean geometry are true? How do we know the truth of the axioms? Okay, so one possible answer is we had much later German and British idealism. In the track of post-Kantian idealism, the idea is that our mind shapes the experiences we get, and our mind actually orders the experiences we get into a temporal order and a three-dimensional space manifold. And so lines, points, and so forth are really actually psychological objects. They're really in our minds, and we know them because, you know, we know nothing better than we know our own mind. And so that's how our knowledge of lines and points and stuff comes from. It's from our own head. Another possible example is logicism. We'll talk about this later in the series as well. This is the idea that it's all just logic. This is all just really a really encoded version of logical, rigorous thought, and there's no objects behind it at all. It might appear we're talking about objects, but we're not. We're just engaging in highly encoded mathematical, logical reasoning. Another is structuralism. So this is the idea that we're not talking about particular objects at all. We're just talking about potential logical structures something can have. We're not even committing ourselves to whether or not anything actually has these structures, has these properties. But if anything does happen to have these properties, then we can describe what the structure of the remaining system would be. So you're not committed to reincarnation. All I'm saying is it just so happens that this is the avenue that the notion of abstract objects had entered into Western thought as a historical accident. And ever since then, philosophers have struggled with trying to come up with a more rational explanation of these things. So this was the start of it all. So this is the birth of what I'm calling real or rigorous mathematics. This is the birth of Western philosophy with the Greeks. And it all comes out of these mystical roots. So let's go back to the American in Paris analogy from the start of the show. Well, if you have a mathematical background, that's why you got into these videos, or you're really used to mathematics. Now you've eaten some snails. What do you think? I'll leave that up to you. And where did I get this stuff from? Well, here's some good sources. First of all, let me recall that the religion of the Axial Ages is where I got all my information on Axial Ages. And then here's just some good books on the history of mathematics. The History of Greek Mathematics, Volume 1, From Thales to Euclid, by Sir Thomas Heath. And A History of Philosophy, Volume 1, Greece and Rome, From Pre-Socratics to Plotinus, by Frederick Copleston Doubleday. Another source is I have these slides that you're seeing right here are all on my personal website, which is at the bottom of this page. And so there you go, the mystical origins of real mathematics and Greek philosophy. So that kind of tells you the sort of intellectual context around which this all happened. Now we know the historical context, the intellectual context. With the next video, what we're going to do is we're really going to start looking at the particular people and what they did. So we're going to start talking about, Thales and people after Thales and stuff like that, and what they were saying. We're going to go back over Plato again in much more depth and detail. Now that you kind of see what's going on in the air, you'll be able to understand much better where each person is coming from as we tell their story and what they contributed. Okay, well, thank you again for joining me. Hope you enjoyed it.